Looks like this stream is running. Hi everyone, I am TigerHawk23, and today we are going to write Mastermind. That's a little board game. The basic premise is 2 players. One has a pattern that they come up with, and the other player has to guess the pattern. And they do this by just first guessing an arbitrary pattern, and then the player who came up with it has to tell them how close they are, basically, by telling them how many parts of the pattern are the correct glyph and in the correct location, and how many parts they have that are the correct glyph in the wrong location. So, that's the classic version. Has each glyph is a color, and there are 6 colors, and and the pattern has 4 components. There's going to be a loop somewhere. How about we're going to have the computer be the player who comes up with the code. So we're going to have a random element. Can I do a random sampling of a string? Yes, I can. Okay. How about pattern equals, now we need 4 of them, so it's going to be something with 4. And actually, no, not sample. Random.sample is a selection without replacement, but the actual game can have replacement, can have 2 or more colors that are the same. So we're just going to pick 4. We're going to do random.choice. Can I do choice on a string? No. Oh. Yes, I can. Okay. We're going to do random.choice. Let's do lowercase, A, B, C, D, E, F. For doesn't matter in range 4. So we're going to do something 4 times, and each of those times we're going to create a list element that's a random one of these, a random letter. For debugging purposes, definitely. Let's do this, so it'll print each letter instead of a list. Nicer to look at. Okay. There's going to be a loop. How about a function? Guess. Does it need a parameter? I don't think so. Not that I can tell right now. Some of you who have watched my streams before will probably have noticed that I have a habit of changing things as I go along. Like, we're going to use a while, no, we're going to use a for, no, we're going to do something completely different. How about we use recursion? That sort of thing. Anyway, while guess, this is going to be while the game is running. print actually, it should print something on every guess. So this is going to be pass, and then when we're done, we're going to say print done. So basically everything is going to happen in guess, so it's not just a guess. Running. While running, that's good. There's going to be input of some kind. Guess equals input. What will the prompt be? Anything? How about question mark with a colon? I don't know. All right. So I'm thinking what we'll do is first we'll check for how many of the correct peg color, how many of the correct glyph we have, and then go through it again and change some of those into correct glyph in the correct location. And we just need a count of them. So, and I'm looking at the Wikipedia page for Mastermind. If there are duplicate colors in the guess, they cannot all be awarded a key peg unless they correspond to the same number of duplicate colors in the hidden code. For example, if the hidden code is white, white, black, black, and the player guesses white, 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 black, so that's 3 whites instead of 2, the code maker will award 2 colored key pegs, meaning correct glyph in correct location, for the 2 correct whites, and nothing for the third, as that third white peg doesn't correspond to anything. And 1 colored key peg for the black. Okay. No indication is given of the fact that the code also includes a second black. Alright. Makes sense. So we need a count, basically, of how many of each thing there are. How about a counter? That would be collections. Counted collections dot counter of the pattern. All right. So if we would need each value in the counted thing, if we have 3 whites and the player guesses 2 whites, then they get 2 for this. If there are 2 and they guess 3, they also only get 2, so they get the max of whatever that is. Okay. So actually, if there only be 4, do we need a counter? I don't know. It does describe what we're doing, so it's probably best to use that. Can we use close? How about close? close is not a built-in function. It is a method for some standard types. There's a close method for file handles. I'm going to use it for ones that are close. Equals a sum. We're just going to put all those together. So it's the smaller number of min of something for something in counted. Okay, and what does counted have? It has key and value. Okay, let's make a counter out of this. Equals another counter. I have a feeling I'm overdoing this. Maybe. I don't know. We'll find out. So we're going to go through each one and find the minimum. We have so for example, if the code is 3 whites and 1 black, and the guess is 2 and 2, then we would have a counter for counted of white and 3 and black 1. And we would want to look at the guesses white 2. So if we wanted to look at the same key, the same color of the peg, that would be V for the quantity of that color in counted. And in guess count, it would be guess count K. V and guess count K. For K being counted. Okay. So we would have white 3 and black, or white 2 and black 2. Was it, which one was the guess and which one was the code? Let me check. The hidden code is 2 and 2 in their example, which I am using right now. So we have white and 2 for K and V. So we go through counted, and we have white 2, and we get the minimum value of 2 and guess count of white, which would be 3, and that gives us 2. And then we have black, which is also 2 for the next K and V, and then we would have 2 and guess count black, which would be 1. So that would say only 1, because they only have that 1 in the right place. Okay, so that's how many are close or better. And now we need to take out how many are in the right place. Exact equals, let's also get a sum. A equals B for A, B in zip pattern and counted. That should work. Let me go through it and we'll make sure. We're going to zip the pattern, which is the official code, and no, not counted. What am I doing? Guess. The pattern and the guess. So we're going to go through both of those together with the corresponding first element and second, third, fourth. And for each of those pairs, we're going to check that they are equal. And we're going to find the sum of how many are exact matches. And then we do close minus equals exact. This is shorthand for close equals close minus exact, because the ones that are exact have their own indicator. And then print how about exact something close something else. Oh, there's someone in chat. It's GhostScript. Hello again. Asks whether I got my cell phone memory issue resolved. My workaround was to delete some apps that I wasn't using, like Skype that I wasn't using at the time. OneNote, which is kind of big, was like 150 or 200 meg. That's gone. Especially because there's an app already included called WPS Office. Don't know what it's from, but it allows me to read and create documents, text, spreadsheet, some other stuff. I don't know. But yeah, so there's a built-in one that I can't remove anyway. So I'll just use that instead. How much memory do I have right now? Let's see what it has. I actually this morning got an update from AT&T, my network provider. So hopefully that didn't eat up all my memory. 2.9 gig used out of 4.1 total. So I have 1.2 gig left. Should be reasonable for app updates. If I run into more problems, what I might do is uninstall updates from the apps I don't use, like Twitter. I let it, when it says Twitter has an update, I just say update whatever wants to be updated. But what I can do, I think, is uninstall updates, and that should free up some space, I hope. So we'll see. I may or may not need to replace this phone in a few months or a year or whatever, but it was $40. It's not bad. I wished it lasted longer. Could last longer. I wish I had hopes for it lasting longer. I did some looking around online. There's something you can do with a phone called rooting it. Actually, in a previous stream where I was talking about this phone, I think Parth was recommending various root applications, meaning basically you can get root access on the phone to be a super user or administrator, and then you can do whatever you want with the phone, like remove apps that you don't use. Looking at the XDA forums, which is like I think the Android forum for people who like to mess with their phones. There was like a 50-page thread started last year and still going. This phone is not rootable. Seems to be the only one they've ever come across that has stumped them, because A, there's not enough interest in it, and B, some people were saying there's like a hardware protection of some kind that you cannot bypass with just, code. So we'll see what happens with this phone, but for now, it is okay. And that's as much as we can ask on some days. Exact. This many. Close, that many. And we'll format that with exact and close. We print that. then we will return pattern is a list. Oh, here we are. Let's do this. Length equals 4. Length. Notice I'm not using len, L-E-N, because that is the name of a built-in function, which I might have used, but didn't actually. It's good practice to just not mask the names of built-in functions. You never know when you're going to want to use them. If you have a length of something, don't name it len. If you have a list, don't call it list, because then you can't use the list function. Same for set and dict. If you have a string, you can call it string, not str, or else you won't be able to convert things to string, and so on. Return exact equals 4. No, equals length. The number of exact matches is the length of the code. So if it returns, no. If it's still running, means it's not the same. So while it's not the same, don't do anything. But as soon as it is the same, this will not be satisfied, and it will print done. It's generally good to test your programs before you think you've finished writing them, but we shall see. How about, where do I put this? Hard drive access stuff. Give it a second. Python scripts, and how about calling it Mastermind? Okay. And let's turn on this dealie and do py mastermind. It's CBCE, just so we know. About AAGD. That should be nothing. That's wrong. Okay. It's the close. Okay, something was wrong there. 4KB. Oh, no, counted as a dictionary-like thing. I need a view of the items. Whoops. Actually, I might as well just do this and do counted K and guess count K. That's pretty clear. Alright, let's try that again. EDEA. Maybe I should have used uppercase so that I could be a little clearer to read. That's okay. EDEA. How about FFFF? 0 and 0. Very good. It's a good start. How about FEFF? That should be exact 0, close 1. Aha! How about all E's? There should be 2 exact and no close. Aha! Very good. If I only have one bug in this whole thing, and something silly like forgetting about item view, I will be very pleased. There is something to be said for, this is a technique called rubber ducking. No offense intended to you, audience, but you are rubber ducks right now. This technique is pretty simple. You take a rubber duck, and you put it on your desk. And while you're coding, you occasionally stop to tell your rubber duck what you're doing. Like, I'm gonna go through this dictionary-like thing with this, and then and then wait a minute. Don't I need items? Oh, thank you, rubber duck. The rubber duck doesn't do anything, but it's the process of explaining your code to someone to help find problems. And it actually works very well. Doesn't have to actually be a literal rubber duck, but that's the idea. And since I have you, audience, I'm kind of rubber ducking with you. So I do something and then I explain what is happening. And you'll notice that sometimes I'll write something and then I explain and I go, wait, no, that's wrong. Like when I had guess in here, and then I'm like, no, was it this one? Yeah, I had like pattern and counted or something. But yeah. So let's continue with this EDEA. Exact as 1. That's right. EDEA. That's good. This seems correct so far. Let's try DEAE. That should be 4 close and no exact ones. This is working. How odd. EDEA. Done. That's it. That's the program. I don't know what else to change. I don't know. I don't know. Length is hard-coded, and this is hard-coded too. The thing about changing these is that it's not like just how big of a triangle do you want to draw. It's actually related to the functioning of the game itself. If you have a really long pattern with lots of potential glyphs, it takes forever to guess. The actual game involves a limited number of guesses, like 8, 10, or 12 or something. This one allows unlimited choices because I felt like it. We could include a counter. We could have done 4 attempt in range, 12 or something. If running if not running, break. Could do that, and that would give us at most 12 guesses. It would run running, and as soon as these are equal, this expression would be false, and then this would, if not something false, meaning that this whole expression would be truthy. So if this truthy, it happens, break. And break and print done. Else. Game over code was something, and we would format that with nothing.join pattern. That's pretty much it. Just discussing a feature I wasn't going to include, and here it is. Did it get significantly longer? I don't know. Back we go from 21 lines to 23. Another 2 lines for actual functionality. By the way, this else is not misplaced. It does not belong to the if, it belongs to the for. You can have an else attached to a loop construct, and if the loop doesn't exit early with a break, then the else will happen. So if it does break, it'll just do this and that's it. But if it never breaks, this will happen, this will execute, and it'll say game over, code was that. So let's try running that, shall we? DAEE. Exact one, close 0. Let's actually DAEE. Let's guess that part. Done, right. It didn't print done. Oh, whoops. Yeah, I got it. Huh. I had it break, and I had something after the break, so it breaks out, and then it doesn't get there. Whoops. So if we will try this, and if the game is over, we print done and we break. Otherwise, we will print guesses remaining, and let's do this. Guesses equals 12. Magic numbers are bad. The only place I have it? Yes, okay. 12 guesses minus 1 minus attempt. Okay. Let's try that again. CCCD. Exact 4, close 0, and done. Very good. Now let's try it with something wrong. Exact 2, close 0. Guesses remaining 11. Good, because I've already used one of 12. On we go. It'll probably explode if I give too many, maybe. Actually, no. Goes to counted and zip. It just won't include the last one. Guesses remaining 0. Game over. The code was AEAE. Yep. Perfect. I literally don't know what else to include. There's a few variations for this game. What have we got as far as variations? Algorithms, variations, varying the numbers, the number of colors and the number of holes, the number of, that's how many glyphs there are, and how many, and the length of the pattern. Represents different levels of difficulty. Another common variation is to support different numbers of players. All sorts of things. So we have the number of colors, which is the number of possible glyphs. I could accept that as a command line argument. I don't think that really adds anything. We've seen that before. I'd import sys and then some kind of error checking to make sure it's there. Length equals sys.argv1, guesses equals sys.argv2, and this would be a slice with sys.argv, 3 or something with like more. OPQRS TUVWXYZ. It doesn't really matter. Doesn't substantively change anything. That's just getting the arguments from the command line. It's pretty trivial. We've seen that before. Not important. So I think that's the game, isn't it? That we could probably take out this. Maybe we'd do that, and then say for debugging purposes, so that we have a useful. I don't that really is just for debugging purposes. If we wanted to do it later, we could. Yeah, I don't know. So the algorithm worked perfectly the first time. I had print and break reversed, so that's something. And I had iterating incorrectly over the dictionary, because the collections.counter is a dictionary-like object. I think that was it, wasn't it? And then the rest was just write, and there it is, 25 lines. So there you go. There's Mastermind. It was simpler than expected. So I think that's the stream. Tomorrow is going to be a game, playing one, not writing one. And Python's pretty cool. You can do some fun little stuff as long as you have an idea for what you're going to write. If you just sit down at an interpreter thinking, I'm going to write code, it doesn't really work. You have to have a plan. So that turned out pretty well. I'm pleased with it. Thanks for watching, and thanks for joining me in the chat, GoScript. And yeah, remember to like, comment, and subscribe. Feel free to comment asking questions about specific things or other techniques. I don't know. But thank you for watching, and I will see you next time. Have a good one.